Hello chemistry and welcome back. In this video we're going to be talking about ionic naming. Now ionic naming is a little more complicated than covalent naming because in covalent naming we just state 1 carbon, 5 oxygens, and we're done. We've just stated the entire name. But in ionic naming it's all about charge balancing. So we have to make sure that our charges cancel. So because of how ionic bonds work, instead of stating there's 3 of the first thing and 2 of the second thing in the name, we instead just state both halves of the name. So, for example, let's talk about sodium chloride. Okay. This name tells us everything we need to know in order to write the formula. Now, most of you probably already know that the formula for sodium chloride is NaCl. I'm going to show you why that is. So, first off, ionic naming and ionic formulae are all about the charge. This is why I gave you polyatomic ions in Unit 2 to work on memorizing. So hopefully you've done that, because ionic naming, you have to know your polyatomic ions in order to do this. So those of you who haven't learned your polyatomic ions are going to start really struggling soon. So this is the part where I said you must know them. Okay, now we're starting off with non-polyatomics, some simple ionic compounds. Okay, now before we go too much farther, the first thing I need to mention is that most ionic compounds are a metal and a nonmetal. We talked about that when we did bond types back in the last unit. What we didn't mention is that most metals can have multiple ionization states. That is, they can form multiple charges. Now, this is overwhelmingly, this is an overwhelming majority of the periodic table metals can do this. It is everything in the D block, or almost everything in the D block, almost everything in the F block, and all of the post-transition metals. So all of the transition metals, all the post-transition metals, all the lanthanides, and all the actinides can form multiple charges. And over time, you're going to start to learn what those charges tend to be for different elements. But some of them have 4 or 5 different possible charges. And so to note this, I'm going to come back to this one in just a second. I'm going to jump instead to iron 3 oxide. Okay, iron 3 oxide is the name for a compound called red rust. There is also iron 2 oxide, which is black rust, if you've ever seen that. The Roman numeral here is extremely important because it tells us which charge the iron actually has. So the 3, the Roman numeral, is the charge of the iron. So we know that this is going to be iron, which is Fe, and oxide, which is O. Now, we have stated here that the iron has to have a charge of +3, and we know, because of our polyatomic ions that we memorized, that oxide has a charge of -2. Well, in order for this formula to work, the charges have to cancel. And they need to be the most reduced form that will cancel. So, what we have to determine then is how many irons are there and how many oxygens are there. Well, if it's a +3 and a -2, then it's going to need 3 of these and 2 of these, which we can tell because 2 positive 3s would give us a +6, and 3 negative 2's would give us a negative 6. Positive 6 and negative 6 cancel each other out. Okay, so then our formula for iron 3 oxide has to be Fe2O3. There's 2 irons, which give us a positive 6, and 3 oxygens, which gives us a negative 6. And this is how most compounds are going to work. So, for example, Cobalt sulfate. Okay, cobalt, we know, has to have a charge of +4 because that's what this Roman numeral tells us. And by the way, the reason it's positive is because irons always form a positive. Metals, I think I misspoke there, metals always form a positive ion. That's one of the things you learned in Unit 1. Metals will always form a positive ion. So cobalt 4 has to be a +4 charge. Okay, sulfate is a polyatomic ion that we learned, and it is formula SO4, and it has a charge of -2. So we have +4 and -2. Well, we need to cancel out our charges, so we need 2 -2's to get a -4. So our formula for this one would be COSO4 2. Now this is where parentheses come in. Okay, it's not COSO42. We don't have 42 oxygens in this. We have 2 sulfates. So we have to put parentheses around the sulfate ion because we have 2 of them. Okay, now here's the reason I'm coming back to this one. There are 13 metals on the periodic table. I think it's 13. It's not 13. Hang on. I'll be right back. I knew 13 wasn't right. It's 15 metals that have only 1 charge. Now, these are not the only 15 metals, on the periodic table that only have 1 possible charge. They are the only 15 that you have to worry about. There are a couple of others that only have 1 charge, but we're not going to really deal with them because they're extremely rare. So, those elements are all the metals in group 1, all the metals in group 2, that's 12, and then we have silver, move a little closer, silver, zinc, and aluminum. Everything in group 1 can only ionize to a charge of +1. Okay? Everything in group 2 can only ionize to a charge of +2. Okay? And that is a constant. That is not something that ever changes or ever fluctuates. That will serve you well in college to know that everything in group 1 is a +1 charge, and everything in group 2 is always a +2 charge. That is constant. Okay, the other 3 that you have to know for me are aluminum, zinc, and I can't talk. Aluminum, zinc, and silver. Silver is always a +1 charge. Zinc is always a +2. And aluminum is always a +3. Okay? So 3, 2, 1, or 1, 2, 3. They are also in groups 13, 12, and 11. So that is something that helps some people keep them straight. Okay, so for those 15 elements, we do not put a Roman numeral, which is why sodium chloride doesn't have a Roman numeral in it, because sodium only has 1 possible charge. It has to be a +1. Okay, so sodium is a +1, and that's Na. Chlorine is a -1, it's a halogen. So +1, -1, they cancel, no subscripts necessary, it's just NaCl. Now, that is all I plan on doing right now. Now, I am going to make myself available for ionic naming help over the next 3 days. You need to be contacting me if you're stuck on some of this. Okay, if you need a little extra practice or a little help, let me know and we can go through a couple of these. We can do a video call or you can come up to the school as long as you're not quarantined and we can work with you on that. Okay, but this is what we're doing for the next 3 days. Now, the worksheet that I'm going to post is going to be broken up into several smaller parts, I think, because that's the way it was in the past. However, that seemed to just confuse a lot of people. So I'm on the fence, but I might decide to just open it back up and just put all of them in one big list. So just be aware, I haven't decided on that yet. It will be broken up into at least 2 parts because for half of them, you're going to have to give me the name from the formula, and for the other half, you're going to come up with the formula from the name. So this is coming up with the formula from the name. In the next video, I will show you how to determine the name from the formula. And it's not that hard. It'll click pretty quick. It's actually probably easier than this is, provided you know your polyatomic ions. So hopefully you know those. That's it for this video. I will talk to y'all guys. I'll talk to y'all later. Have a wonderful night, and I look forward to seeing y'all back in class.